Hello, my name's Dr. Simon Benson. I'm a Chartered Naval Architect and a lecturer in the School of Engineering at Newcastle University. My research and teaching interests are in marine structures and hydrodynamics, which means I'm interested in objects like this, which is a marine propeller, both in terms of its efficiency, but also the way it flexes and bends when it's operating behind a ship. I spend a lot of time here in the Marine Propulsion Lab at Newcastle University, and behind me we've got a really large water flume which we use to test propellers and all sorts of innovative devices that we use in marine technology.
Hello everyone, I am Dr. Mariam Hartunian and I am a lecturer in Marine, Offshore and Subsea Technology Group in the School of Engineering at Newcastle University. My academic background is naval architecture, and I'm predominantly interested in doing research in marine hydrodynamics. So that is maneuvering and seakeeping of marine vessels, which is how ships, boats and underwater vehicles move in the ocean, interact with the ocean environment and navigate.
Ships have been trading the seas for thousands of years, but it's only until relatively recently that we've moved from the age of sail to the age of steam. And with that came a completely new way of driving a ship through the waves. Sails driven by the wind gave way to screw propellers driven by an engine. Perhaps the most famous use of a propeller was for the SS Great Britain, which was designed by Isambard Kingdom Brunel and sailed across the Atlantic under steam propulsion with a propeller in the 1840s. And from then on, the propeller became and then remained the dominant technology to drive large ships. In our modern interconnected world of global trade, it's literally pushed by the screw propeller, just like the one you see behind me, driving ships, which are some of the largest man-made structures ever to be built across oceans, carrying millions of tons of goods and raw materials every single day. And propellers themselves might not seem to have changed much in the last 200 years since Brunel's iconic voyage across the Atlantic. But in reality, the revolutionary developments in ship size and function have also needed huge development of the propellers themselves. The physics of a propeller are very complex, and naval architects continue to think about many aspects of their design, including their efficiency, things like their radiated noise signature and impacts on the environment, their robustness, and the complexities of the fluid flow around them, including a phenomenon known as cavitation, where bubbles are actually created by the propeller and create noise, inefficiency, and erosion of the propeller blades themselves. In Newcastle University, we have specialist facilities for studying the performance of propellers, including a towing tank to measure the drag and a cavitation tunnel to visualize and measure propeller performance. So despite all these advancements, a big question still remains. Are ships always going to be pushed by propellers, spinning around, driven by an engine connected to a shaft? Or are we going to see new revolutions in these propulsion devices for ships?
Taking into account the significant effect of climate change and the push for a greener future with lower greenhouse gas emissions, any new technology that we investigate, any new innovation that we make, it is paramount that these technologies are environmentally friendly. One of those, when it comes to shipping, are flattening rotors, as you can see in the picture. So flattening rotors are like the modern versions of sails. They are large cylinders on board ships that are turned by motor, and when the wind hits them, they produce a lift which pushes the ship forward. They are very efficient because they produce a lot more power than they take in. Of course, route optimization is very important when it comes to flattening rotors because there are at certain angles of winds that they perform the best, but when they are performing in their optimal condition, they are really good. In addition to that, there are still investigations going on in including conventional sails on ships, but with the use of new technology and new materials when it comes to the design of the vessel. And with regards to both these technologies, there are colleagues of mine at Newcastle University who are researching in these areas and looking into the future of these technologies.
Another way to answer this question is to look at some of the latest innovations and disruptions coming to the shipping industry from other sectors. And one of these is from the world of sport. more specifically, perhaps the pinnacle of sailing competitions, which is known as the America's Cup. Over the past 20 years, yacht racing has seen a revolution in the way these high-performance boats are powered through the water. Okay, they still use sails, but look at the hulls that they're connected to. These use amazing new technologies such as hydrofoils, allowing the boat to lift up out of the water, and lightweight materials such as carbon fiber, which enable this power to actually be transferred into lifting the boat up and flying through the water at incredible speed. So the America's Cup is like Formula One. These boats are fantastic racing machines, but it's kind of difficult to see how they connect to, for example, a large boxy cargo ship sailing halfway around the world every month. But just like in the auto car industry, we see that the teams and technologies from the America's Cup are bringing their ideas and their disruptive technologies into the commercial sector. So, for example, in the UK, we see several America's Cup teams in terms of BAR Racing and Artemis, and they're developing technology companies alongside their America's Cup teams with exciting ideas for hydrofoiling cargo ships, integrating novel propulsion systems, and using alternative propulsion methods.
When it comes to environmentally friendly technologies, one of the fields to look into is bioinspiration. For example, the propellers on submarines, underwater vehicles, as well as ships, the noise and vibration due to them can spook some animals, especially marine mammals, and therefore cause them damage and distress. So one of my personal research areas is to look into alternative bio-inspired propulsors. So I look into flexible oscillating foils and investigate their efficiency in terms of being used as a bio-inspired propulsor, as well as looking at marine animals for inspiration in terms of their maneuvering. Marine animals are flexible, they are highly maneuverable due to their flexible body and their particular propulsors. And we can learn from them and incorporate that into engineered vehicles that are more maneuverable. So at Newcastle University, we do mathematical modeling of these flexible oscillating foils, as well as validating them through experiments.